Hello friends, welcome back to my YouTube channel MS Maths. In this video, I will discuss sequence of real number and it is part 2. In part 1, we have already discussed about the sequence and its constructions and its property and basically types of its sequence that we have already discussed in the previous video. In this particular video, I will discuss convergency of the sequence, the definition, what is the meaning of the convergency of the sequence. I will discuss this with the examples, and after we'll see the monotonic sequence and convergency of monotonic sequence. Either it may be monotonic increasing, monotonic decreasing. We'll discuss the convergency and some important result based on the convergency of the sequence. So this video is helpful for IIT JAM, CSIR-NET and GATE, and my name is Manoj Solanki and I will start this topic. Please like the video, share the video and subscribe the channel to get more videos related to the higher mathematics. Now let us start with the definition of the convergent sequence. What do you mean by convergency of a sequence? So whenever we will have a sequence, for example, it is a sequence denoted by like this is a an sequence, and either it may be monotonic increasing, decreasing, or whatever this sequence, the sequence is said to be convergent. Okay, this sequence is said to be convergent to a real number L. So it means my sequence is converging to a real number L. It means L belonging from real number. If each neighborhood of L, it means L minus epsilon. Okay, it means L minus epsilon, L plus epsilon. If each neighborhood of L contains all the terms, or we can say the finite many terms of the sequence. So it means the neighborhood of this particular number, which is belonging from real number, which is nothing but a real number, if it will contain at most, or basically we can say that all the terms, or we can say that finite terms of sequence, then we will say my sequence is converging to that particular L, and the sequence is known as convergent sequence. If such L will exist for that sequence, then we can say that my sequence is convergent. Okay, so this is the definition kind of thing. We can just relate like limit of the sequence. It means whatever we have discussed in this in the like definition, we can just denote by. So it can be denoted by the limit of, okay, we can say the limit n tending to infinity. It means if my terms of sequence will goes to infinity of an, that will be L, and where my an tending to L as n tending to infinity. This is what the meaning of the convergency of sequence, and where L is called the limit. This L means that the limit of sequence an. Okay, so if every sequence, or if every terms will contain in this particular neighborhood of L, then we'll say that convergence, my sequence is convergent. But it is not necessary that every time the limit will be the limit point, whatever the concept we have discussed, limit point. See, in the case of limit, be the limit point. Okay, it will be the limit point, but it is not necessary that limit point be always a limit of the sequence. This is the important concept here. You will have to remember it. Okay, no need that limit point will be every time, or it will be always a limit. But if it is a limit, then it is always a limit point. It is at least like one of the limit point of that. Okay, now we will take one example for this. So for example, sequence minus 1 power n. Okay, this is what, if I will write this sequence, it is minus 1 1 minus 1 1 and go like this. So what is the limit point of this? So the limit point means the term of sequence which is repeating infinitely time. So minus 1 will repeat infinitely time. Yes. And plus 1 also repeat. Okay. Then minus 1 and plus 1 both are the limit or limit point of this. But 1 is not limit, but 1 is not a limit of the sequence. Similarly, minus 1 is not a limit of the sequence. So this is what the thing that we have discussed. Okay. So here you can see limit point is not limit. Okay, and even though for this particular case, okay, why these both are not the limit point? So what is the okay? Why these both are not the limit? Yeah, these both are the limit point, but why these both are not limit? So if I will take L, let's say my L is equals to, I will take 1 minus epsilon, 1 plus epsilon. Is my all the terms are belonging? Is my terms are the terms of sequence are belonging from this particular neighborhood or not? This does not belonging. It is not belonging from this particular like neighborhood of this particular L. So this is the reason that 1 and minus 1 are not a limit of this particular example. Okay, and this is one of the important reason. Now next we will discuss what is the convergence sequence and what are the example of convergence sequence. So how can we identify for a convergence sequence? So we'll just check it by definition. So we'll take epsilon greater than 0 by definition. We can just start by definition. We'll just start, it will be greater than of, because it is a 1 by n and n is belonging from natural number in sequence also. So here it will be greater than of 0 but less than of some epsilon. Okay, now if I will take what is my sequence here, if I will take 0 as a point, or let's say my L is equals to 0, then if I will substitute like this 1 upon n, okay, either it will be 1 plus n. Okay, one second. We can take the example. Okay, if I will write like this, so every terms will belonging from minus of epsilon to epsilon. Because of that, it is the interval. Let's see. It is my minus of epsilon and it is my epsilon. And this is what? 0. My all the terms will lie here only. This is 1 by n. And simple to find that my sequence is convergent or not, just find the limit. Okay, just find the limit n tending to infinity to 1 by n. It is nothing but 1 over infinity, and it is 0. If it is 0, it means exist. Exist and unique. Exist and unique. It means this is nothing but the limit of sequence, and my sequence 1 by n converging to 0 as n tending to infinity. Similarly, what is this? This is a constant sequence. Okay, this is nothing but constant sequence. If it is a constant sequence, then of course each term of A will be A minus epsilon and A plus epsilon. It means that the sequence A converges to A as n tending to infinity. So this is the limit of this particular example. Let's say if it is 1, then it is a convergent sequence. Yes, it is a convergent sequence and converging to 1. Okay. Next we have 1 by root n. Just we will find the limit. So if n tending to infinity, 1 over root n is nothing but 1 over uh, infinity, and this is also 0. It means that sequence 1 over root n is converging to 0 as n tending to infinity. This is also convergent. Let's say this is 1. This is the example. So again, limit n tending to infinity, 1 upon 100 n is 1 upon infinity, and this will be 0. It means that the sequence 1 over 100 into n is converging to 0 as n tending to infinity. So this is the one of the easiest way that you can find the sequence is convergent or not. Now, while if you have these types of cases where in this minus 1 power n and this occurs, so you can just write it in simply if my n is odd and n is even, it means that if my n is odd, it is minus 1 over n. If n is even, it is 1 over n. Now, it is my an. If I will take limit n tending to infinity of on minus 1 over n, it is 0, and also on limit n tending to infinity on 1 by n, it is also 0. It means that these both are unique and equal. So it means that minus 1 over n divided by n converging to 0 as n tending to infinity. This is also convergent sequence. Now, which one is not convergent? That how can we find? Just simple. Just take one example, n square. Is it convergent? It will not convergent. As n tending to infinity, the sequence n square does not go to any of, or does not go to, or we can say it will go to infinity. It means not convergent, or we will say it is a divergent sequence. Okay, these are these are some example of convergent sequence and divergent. Now, next we have some result related to the convergent sequence. Every convergent sequence is bounded. Every convergent sequence is bounded. Let's say one example. I have one example 1 by n. So it is what? 1, 1 by 2, up to 1 by n. Now, if n tending to infinity, what is the upper bound of this? Upper bound, or we can say supremum. Supremum of this is 0. Supremum of this is 1. And what is the infimum of this is 0. If supremum and infimum both exist, it means my sequence is bounded below and bounded above. Due to this, it is bounded above. And if it is exist, it means bounded below. If these both exist, bounded below plus bounded above implies that my sequence is bounded. We know that 1 by n is convergent sequence, that we have example. Next, we have unbounded sequence can't be convergent. Let's say n. It is what? Unbounded sequence. It will be 1, 2 to infinity. It means what is the supremum? It is does not exist. But what is infimum? It is 1. So here it is unbounded above. If it is unbounded above, then it is what? Unbounded. Simply say, you can say it is unbounded, and this sequence is divergent sequence, not convergent. Bounded sequence may or may not be convergent. See, this result and this result is totally depending. Convergent sequence is always bounded, but it is not necessary that every bounded sequence is convergent. Okay, for example, we can take one counter example that is very important, minus 1 power n. It is what? If I will write this, it is nothing but what? Minus 1, 1, minus 1, 1. It is a bounded. In between what? What is the supremum? Supremum is 1. What is the infimum? Is minus 1. It is bounded, but not convergent. It is basically oscillating. It is also not divergent. It is oscillating between minus 1 and. Okay, this is the thing. So we have the result. It is not necessary. My convergent sequence will always bounded. See, if I will write this, then I can easily write this result. So the convergent sequence will always bounded, but converse need not be true. Okay, but converse need not be, maybe, or we can say maybe. Next, convergent sequence converges to the unique limit. Of course, whatever we have seen, minus 1 power n by n. So for this 1 by n, n minus 1 by n. For this limit is 0, it is also 0. If it is convergent, and this is what? Unique limit. Okay. Next, we have convergent sequence has unique limit point, but not convergent. Okay. Convergent sequence has, convergent sequence has unique limit point, but not but converse not true. Yes, but not converse. It means converse means opposite, but opposite is not true. It means it is saying that convergent sequence has unique limit point. So for example, if I have a sequence, let's say 1 by n, what is the limit point of this? It is 1. Okay. Yes. Yes. If my sequence is convergent sequence, let's say 1 by n, it has unique limit point. What is the unique limit point? That is 0. But let's say if it is a minus 1 power n, it does not have unique limit point. It means it is not convergent. Okay. Next, bounded plus unique limit point will be the convergent. See, whatever we have seen, we have one result. Okay. So the converse is not true here. From here, it is not true. But what if it is bounded plus unique limit point? We have 4 result. Just focus on it. First one, I want to explain here. If it is bounded, we can't directly say it is convergent. Unique limit point, we can't directly say is convergent. If these both will get together, it means my sequence is bounded as well as unique limit point. Then only we can say yes, it is convergent. This is again a very, very important point. This is again a very, very important point. Okay. Alone bounded, we can't say that it is convergent. Alone unique limit point, we can't say it is convergent. But if these both will come together, bounded plus unique limit point, then we will say it is convergent. Okay. Next, we have some point, that is convergency of monotonic sequence. Monotonic sequence means monotonic sequence if it is monotonically increasing sequence. If it is bounded above, for example, monotonic increasing sequence, that we can take one example. Monotonic increasing sequence. Okay, monotonic increasing sequence will be the monotonic increasing sequence will convergent only if it is bounded above. If it is not bounded, for example, n, it is unbounded above. Unbounded above, it means not convergent. Or let's say monotonic decreasing, if it is unbounded below, bounded below. If it is, yes, it is bounded below, it means supremum is 1. But what about infimum? It is 0. It means it is bounded below as well as it is a bounded sequence. It is a bounded sequence. So it means that it is convergent. So this is what about the convergence of sequence. This is all about the result and convergence. It is very easy to find the limit of sequence, and you can identify either my sequence is convergent or not. So this is all about the topic. So thanks for watching my video. Keep watching MS Maths. Thank you. Bye bye. We'll meet you in the next video. Keep watching the MS Maths. Thank you. Bye bye.